Assalamualaikum and hi to everyone. Today I will talk about the introduction of Self-Organizing map, which is SOM. The Self-Organizing map is one of the most popular neural models. It belongs to the category of the competitive learning network. The SOM is based on unsupervised learning, which means there is no human invitation is needed during the training, and those little needs to be known about characterized by the input data. For example, use the SOM for clustering membership of the input data. The SOM can be used to detect features inherent to the problem and thus has also been called SOFM, which is Self-Organization Feature Map. The Self-Organized Map was developed by Professor Koehnen, which is used in many applications. The purpose of SOM is that providing a data visualization techniques that helps to understand high dimension data by reducing the dimension of data to map. SOM also represents the clustering concept by grouping similar data together. Therefore, it can be said that Self-Organizing map reduce the dimension and display similarly among data. Next, I will briefly explain about the algorithm of SOM. A SOM does not need a target output to be specified. Unlike many types of network insteads, where the node weights match the input vector, the area of lattice is selectively optimized to more closely resembles the data for the class the input vector is a member of. From the initial distribution of random weights and over many iterations, the SOM eventually settles into a map of stable zones. For each zone is effectively a feature classifier, so you can think of the graphical outputs as a type of feature map of the input space.
Hello, my name is Ariff Rahimin. SOM have two parts, that is the theory part and the implementation part. And now I will talk about the theory part, the SOM theory. The first thing about the SOM theory you need to know is the learning algorithm. First thing first, in learning algorithm, we need to initialize the weights. The weights are assigned to each connection in the SOM, and the weight belong in the output node itself, and there is no activation function. Instead of being the result of adding up the weight, it is the output node in the SOM itself will become the coordinate in the map. The second step is calculate the best matching unit, that is the BMU. To calculate the best matching unit, you need to know about the Euclidean distance formula, and then calculate it. You need to go to your dataset, and for each row you need to find the node closest to it and then determine it by using the Euclidean distance formula. The minimum value will be called as the best matching unit. Our SOM is drawing closer to the data point by stretching the BMU towards it. The goal is to have our own map. And the third step is to calculate the size of the neighborhood. The meaning of the neighborhood is the surrounding of the BMU is called the neighborhood. By using the simple application of Pythagoras, we can calculate each the size of the neighborhood, the surrounding the BMU, by using the formula of new weight equals to old weight plus learning rate times by input vector minus old weight. This is the Euclidean distance. Okay, that finished the part of theory. Now I will talk a little bit about the implementation part in SOM. Implementation part of SOM in our dataset. Our project is mostly about bananas. They classify bananas into three categories, that is unripe, ripe and overripe. if our dataset is full of images, how do we implement SOM? Well, we use colors in the images and we arrange it by using SOM. And we use this Python programming language with several libraries, and the crucial one is to use the mini SOM libraries, as it have the built-in SOM calculation in it, NumPy for basic mathematics calculation, Matplotlib for the chart representation, and Python imaging library to use images file in our system. Now I will make a demo for our system. So we can choose the images in this folder. Try this one for the right banana. As you can see here, this is one of the error. one error. This better one. In this picture, it has categorized and learned the colors inside the images. So we use the color pixel by pixel to categorize and make bounding box by using SOM. And here is, you can see the colors has been reorganized by the mini SOM. Let's try another one. This is pretty noisy image, because you can see we can't use only color, because the leaf and the banana is already the same color. So maybe the learned colors may have a different result from the initial colors. The black one, because of the contrast that is made from the mini SOM, make the shadow become darker. So the learned colors are including the black one also. So let's see for the override. Right bananas. Less yellow color, more to dark and pasty color. So this is our demo for SOM in our dataset, and thank you for listening to me. Thank you.
Okay, hello everyone, my name is Mohamed Fikrun Amin. In this part, I would like to explain the programming system side of our source code. Okay, but first I would like to show the source code first. Okay, in the beginning part we have 4 first lines of our source code. That is importing the necessary library, Python libraries such as Minisum, Curl, NumPy, Matplotlib, just for ease us to implementing the algorithm. Okay, after that we have here we have import the image pisang.jpg, and then after that we reshape the image, the pixel of the image. We replace the value from the range 0 to 255 to 0 to 1. Then after that we build SOM or initialize the SOM algorithm that have 3 times 3 dimension, and then at 2 times 3 dimension, and then with sigma equals to 1, learning rate 0.2, and then neighborhood function is using the bubble function, bubble algorithm, and then we initialize the random weights of each pixels. Okay, after that we starting the weights, we save. After we random the weights, as I mentioned before, we save the weights, and then we train, the training process was begun and involving the weight pixel values of banana image, and then it has 500 iterations. Okay, after that we quantize each pixels of the image. This one is for quantization process, and then this one is creating a matrix 0 that has same dimension as the image, and then after that we place the quantized values into a new image. Okay, we this 0 matrix are filled up by this one, by the pixel that are quantized before, and then after replacing the quantized values into a new image, we show the result and then plotting into a new window.
Assalamualaikum and hello to everyone. My name is Mohammad Azri bin Azmi, and today I will explain about our project result. As you all know, we use banana as our test subject to apply the self-organizing map. To show the result, we use this code, which is this will display the result in 7 times 7 inch of the box plot. Then to locate the original banana image, we use this code, which is to locate it at the top left of the box plot. And then for the clustered banana image, we use this code to place it at the top right of the box. After that, for locating the initial color of banana image, we use this code and placing it on the bottom left of the box plot. And then for locating the learned colors of banana image, we place it on the bottom right while using this code. And this is our final result. In conclusion, SOM is trained for each stage of ripeness, which is from unripe, ripe, and overripe. Each of it has different color palettes. These results have shown that it has learned those color palette and have significant amount of pixel with the yellow color. And then this shows that banana in the figure is categorized as ripe. Application of SOM. There are a lot of applications for self-organizing map. For example, graph mining based on SOM, which is a tool to analyze economic stability. This will help a country to protect their financial from a critical situation. For more details, I will include it in the description. For the last example application of SOM, we also can use SOM to do text clustering, which is the most important in text mining research directions. The text dataset can be divided into different clusters, which is as small as possible, and the distance between the categories is far away from each other. In conclusion, SOM unique training structure provides convenience for the realization of parallel clustering and incremental clustering that can be improved the efficiency of clustering.